We are inside the week 11 problem set. We have already defined instance variables as a variable defined in a class that represents an attribute of an object, and that's from several weeks ago. But this week we introduced a static variable, which is a variable that is shared by all instances of a class. We talked about an instance method, which is a method that requires an object of the class to be created before it can be called. And then we talked about a static method, which is a method that can be called without creating an object of the class. And we looked at the problem set in the context of a instance method. So here we create a new instance of the Mad Libs class, and we use that instance to call fall story, passing the required parameters. All right, so we had to create an instance of the class before we could call one of those methods. But we also looked at in the Mad Libs file where we use read text file, and that's class, but we're able to utilize that without first creating an instance of the class. And so we are able to identify read text file and then use the toString array method inside of that class without creating an instance of a class. And we can do that because that method is static. Okay? Remember, we defined static methods as a method that can be called without creating an object of the class. Well, now we're going to take a look at static variables, static instance variables. And I'm going to create a new file. And I'm going to call it Android. Inside this file, we have to first define the class. We're going to do public class Android. And each Android has a model number and belongs to a specific human. So we have private string model and private string human. Now, androids are really helpful. They can do a lot of things for us, but we want to keep track of how many androids are out there. And we want to do this because scientists believe that if the total number of androids eclipses 30% of the human population, we will be in danger of them taking over. So we want to know how many androids there are. So we're going to do a private int total androids. And we're going to make that equal 0. Now, I'm going to go ahead and just paste in setters and getters for each one. We have get model returns model, set model, get human, set human, get total androids, and set total androids. Now we're going to write a constructor. Oh, let me throw in a toString here too. All right, so the toString is just going to display the Android model, the Android owner, and the total number of androids. So now when we go to write our constructor, we're going to start with a no argument constructor. And we'll make the default model be second generation. That's where the actual model number will go. And this one's going to be a home assistant. Why not? We can call this anything we want to. Just got to put something in there. Wrap it in quotation marks, semicolon. And then the human, our default human, is going to be John Doe. And then each time we create another android, in order to keep track of how many we have, we're going to add one to total androids. Okay? All right, then we have our parameterized constructor. And in that one, we're going to public android string model string human. This dot model equals model. This dot human equals human. And again, we want to increment total androids. So now we'll go over to main. And in main, we're going to create a new Android object. So we're going to do Android test1 equals new Android. And I'm going to pass, I just want to be able to see the different ones that I create. So I'm just going to put test1 model and test1 name. So we're going to test it with a single Android created. Let's see what happens. Oops, I got an error. Oh, because this needs to be test1. And we have Android model, test1 model, Android owner, test1 name, total Androids 1, which makes sense because we've only created one Android. Now I'm going to go ahead, I'm going to throw in a line. Just going to do one line, one space here. Test2 model. Here, we're going to make a few more of these. So we have 3, 4, 5. All right, so now we have 5 Androids. And now we're just going to go and we're going to create 5 Androids. So system.out.println. And we're just going to do, we're going to print the last one and see what we get. In both cases, we have total Androids is 1, but we've created 5 total Androids. And each time we created an Android, we incremented total Androids. So why isn't it adding it up? Well, it's not adding it up because every time we create a new instance, we start off again with total androids being 0. And this is where static variables come in. If we change this private int total androids to static, and then we have to change the get method to static, and in this case we have to keep the public, we add the static. Okay, so we have public static int get total androids, and then we run it, and now we get total androids 5. Because it's static, remember we defined a static variable as a variable that is shared by all instances of a class. So all instances of the Android class are using this same variable for total androids. So every time we incremented it, it added to that total androids, and you know, and that new incremented number goes across all instances. So we could go in and we can print out. Let's print out again after 3. And then after 5, we'll print out 1 and we'll print out 3. So in this case, we're going to print 3. We're going to print 3, and we're going to print 5. So after the first, right, we create the new instance of the object. Test 1 is you have androids is 1. Then after we create 2 more, androids is 3. After we create 2 more, androids is 5. Now look here though, when we reprint out, when we reprint out test 1, androids is now 5. When we print out test 3, androids is now 5 because it has kept track. It's giving us the total number. Now doing a calculation versus population is a whole nother deal process we're not getting into. The point of this was to demonstrate the use of static variables, and hopefully you have a better understanding of that now.